Hey guys, so this is Mr. Boyd. In the next three lessons, we're going to be talking about polynomial expressions. So our first lesson needs to be a lot of vocabulary to see what a polynomial is, how we name polynomials by their terms and their degrees. So let's jump right in. A polynomial is an algebraic expression with one term or the sum of several terms. And if you'll recall from a previous lesson, a term is the product of a number and a variable. Okay? So I'd like for you to take just a minute or two, look through this table and recognize the patterns, and then I would like for you to fill out this right-hand column. Do you think, based on your observations on the left, do you think that the following, negative 15t square root of p, 8 divided by g to the fourth, and so on, are polynomials or not? When you're finished, click the play button and continue. Okay, guys, now that you've had a chance to answer those questions out on the right-hand side, let's see what you put down. So, negative 15t, is that a polynomial? Well, yes, it is, because that is a single term, negative 15 times t. How about the square root of p? This one would be a no, because it's a variable to a square root, just like the one next to it, the square root of y. And also, we could rewrite p as p to the 1/2 power. So if we have fractional exponents, then it's not a polynomial. Well, I should say that fractional exponent on a variable. How about the third one down? G8 divided by g to the fourth. What did you put there? Well, you should have put no. And the reason is, if we rewrite this so that it's not a fraction, notice g would be a negative 4. So if we have a variable in the denominator, it's also not a polynomial. How about the fourth one down? What did you put there? Well, this one will be a yes, because the exponents on the variable are all positive. Okay, moving on down to what's that, the fifth one down. Well, I notice here that I've got a negative exponent on the z variable. So this one's going to have to be a no, because I have a negative exponent on the z variable. All right, how about this next one? See, I've got a negative exponent, but it's not on a variable, it's on a constant. And that's okay. So this one is actually a polynomial, because the things I cannot have uh, cannot have variables in the denominator, which means a negative exponent, and I can have the square root, radicals of a variable. Those disqualify those expressions from being polynomials. All right, let's get on to some more pertinent stuff. So here's what we want to do. When you put a polynomial in standard form, it's written in descending degree order. Now, what do I mean by that? Well, the way you find the degree of a monomial, and a monomial is a single term, the way you find the degree of a term is you add the exponents in that term. So if we look at this first one, I notice that the x is to the first power and y is to the first power. So this would be a degree 2 term. I notice that 9 doesn't have a variable at all, so it's a degree 0 term. So if I'm going to put this in standard form, then I'm going to put the negative 6xy first, and I'm going to put the 9 second. Okay, let's move on to the second one here. So this one has a 1 on the variable because it's a power to the first power. The b here on the 8 has a 1. Therefore, the first term has a degree 1. The second term has a degree 4 because I add those exponents together to find the degree. That pause, guys. I had a phone call come in. Okay, so if I put this in descending degree order or in standard form, then that would mean my negative 8, b, c to the third would be my first term, and then because that 6 is positive, I would use a plus sign, and then my 6x would be my second term. This is what we call standard form. Notice it's in descending exponent order. Degree 4, degree 1, degree 2, degree 0. Okay, let's move on. So now let's look at these terms. Okay, so this monomial, this term right here, is a degree 5. You have to look at each term. Okay, this middle term, the 3, the constant, is a degree 0. There is no variable, therefore it's a degree 0. Constants are always a degree 0. This term has a y to the 7th power, therefore it's a degree 7. So if I'm going to put this in standard form, then I'm going to write it as negative 6y to the 7th plus x to the 5th plus 3. Here again we have the degree 7, the degree 5, and the degree 0. Notice that it's in descending order. Okay, so let's take a look at this fourth one. The fourth one is the first term, the negative 4xy, is a degree 2. The second term is a degree 7 again. And the last one is a constant, so again, it is a degree 0. So if we put this in descending order, that would mean my negative p to the 7th would be first, excuse me, minus 4xy plus 1. Again, let's look at those degrees. 7, 2, and 0. Descending. Greatest to smallest. Okay? Pause the video. I would like for you to complete the your turn problems and then answer the 2 questions down below. Okay, guys, so let's see how you did. So I have already supplied the answers out here. Take a moment to check it and see how you did with those problems. If you need to pause the video to write them in, the correct answers, go ahead and do that now. All right, let's move on. So now we want to look at how do we name polynomials based on the number of terms that they have. So the number of terms, remember terms are the product of a number and a variable or variables. So I notice that this only has one term. And a single term polynomial is called a monomial. Mono means one. Okay? One term, monomial. Okay? A two-term polynomial is called a binomial. Should be noted that terms are separated by addition and subtraction symbols. So I've got one addition symbol, I've got two terms. Okay? Here I've got 1, 2, 3 terms. What do you think a 3-term one's called? If you said trinomial, like a tricycle, you would be correct because tri means 3. And of course, bi, like a bicycle, bi means 2. So 3 terms and 2 terms. All right. The next one, notice we've got 1, 2 terms separated by a plus sign. So this would be a 2-term polynomial. And so this is called a binomial. Okay. Next, I see I've got a 1, 2, 3-term polynomial. So that's 3 terms. And so this would be called a trinomial. Anything over 3 terms is just simply called a polynomial. Okay? So I want you to take a second and fill out the right-hand column. See if you can figure out how to name those based on the number of terms. I'll be right back with you. Pause the video. Okay, guys, go ahead and take a moment now and check your answers. How did you do in this last column out here? And then how did you answer this question at the bottom? How do you determine the classification of polynomial by its terms? Well, you simply count the number of terms. And remember that terms are separated by addition and subtraction symbols. So there's always going to be one more number of terms than there are addition or subtraction symbols. And then mono means 1, bi means 2, and tri means 3. Okay? So if you need to pause the video and check those, go ahead and do so right now. All right, moving on to naming a polynomial by its degree. So we kind of covered a little bit of this earlier. Let's go ahead and take a look at this again, though. So we see we have a constant here. So a constant always has a degree 0. Okay? 6xy. Well, there's a power of 1 on each of the variables. So this is a second degree polynomial. Now, when we look at this monomial, we always add the exponents on the monomial. So there's a 1 here on that b, like we saw earlier, and we add those two exponents. So this would be a 4th degree polynomial or monomial. Okay? X to the 5th. I see that this has a power of 5. This has a power of 0. Well, the way we name a binomial or a trinomial by its degree is we pick the term with the highest degree. So this would be a 5th degree. Okay? Because the highest term, the term with the highest exponent is 5. All right, let's take a look at this one. We got a degree 2, we have a degree 7, and a degree 0. So this one would be a 7th degree because the highest exponent on any term is a 7. The next one down has a degree 6 in the first term and a degree 1 in the second term. So this would be a 6th degree polynomial. Okay? Next, we're going to look at this next one. We've got a 4 and a 5, so that term has a 9 degree or 9th degree term. This is a degree 1 monomial, and this one is a degree 3. Okay? So this one is going to be a 9th degree because the term, the highest degree term is a 9th degree. All right, so this one is a degree 0 because it has no variable, guys, no variable. This is a constant. Even though it's 3 to the 5th, it is a constant number. This one has a degree 2. This one has a degree 1. So this is a 2nd degree. Okay? So I would like for you guys to pause the video and try your hand at the ones on the right-hand side. And then unpause it and check. All right, guys, so we're wrapping up this video here. Go ahead and pause the video real quick, check your answers, and see how you did.